Hope you're doing great. Maxim here. And this video, this post from my secondary Twitter account got pretty viral, and it got 6.2 thousand views, and the founders of Agent Ops AI, for whom I kind of recorded this video, were interested in this work. So I thought to record a video about how I built this AI voice agent that I'm demonstrating in the video. So first, let's dive into the demo and I show you the exact video, and then we'll explain why is it useful and how to build such thing. So I've been going through some Agent Ops documentation recently, and I found this button which says call my agent. So it's gonna be a call, but it's just this form. I decided to improve the user experience just a little bit, and here is what I ended up with.
Hi, Maxime. How can I assist you today? Would you like to continue talking about tool tracking in Agent Ops? Or do you have another question?
Hey there. No, I actually wanted to ask you if Agent Ops is compatible with my current Crew AI setup.
Let me check the Agent Ops documentation to provide you with accurate information regarding Crew AI integration. Please give me a moment. Yes, Agent Ops is compatible with...
Perfect. And can you also tell me how can I track a single agent in Agent Ops? Like, do I use some decorators, or how do I do it?
To track a single agent in Agent Ops, you can indeed use decorators. Here's how you can do it. First, you need to import the Agent Ops library in your agent's code. 2. Decorator use. Apply the Agent Ops track agent decorator to the class or function that you want to track.
Perfect. Thank you so much. And can I please schedule a consultation call with an agent expert?
Absolutely. What would be your preferred time for the consultation call?
Let's do it tomorrow at 2 p.m.
Great. Just to confirm, tomorrow at 2 p.m. Could you please provide your email address so I can send you the meeting details?
Sure. My email address is lyaminky2@gmail.com.
Thank you for providing your email address. Just to confirm, is it lyaminky2@gmail.com?
Yes, it is.
Perfect. Thank you for confirming. I'll go ahead and schedule your consultation call with an Agent Ops expert for tomorrow at 2 p.m. Please hold on a moment while I finalize the details. Your consultation call with an Agent Ops expert has been scheduled for tomorrow at 2 p.m.
Got it. Thank you so much. And do you actually still remember when is my birthday?
Yes, Maxime, I remember. Your birthday is on October 30th.
Perfect. Thank you so much. And well, the last thing is that I want to invest in Agent Ops. Can you help me with that?
Absolutely, Maxime. Are you ready to be redirected to an investment expert who can guide you through the process of investing in Agent Ops?
Yes, sure. Sorry, so can you redirect me to the investment expert?
Connecting you to our fundraising expert now.
Okay, so as you have seen, it's pretty cool, right? And you can use it for all the various use cases. You can build your own like AI voice agent for your business. It can be a towing company, it can be a, let's say, a beauty salon, hairdressing salon, dentistry, whatever it is, that will be taking inbound calls, processing them, storing the relevant user data, as well as, for example, helping to schedule appointments or redirect to other phone numbers in case of important calls, right? So there is plenty of different use cases you can use it for, And let's now dive deeper into the process, how to build it. Yeah, so I have a lot of cool diagrams that I want to show you, and also I will link you a GitHub repository for all the code where you can see everything, and it also has kind of explicit descriptions of all the processes. But stay until the very end, because in the README I don't show how to make AI talk first, which is also very important for the user experience. So this will only be shown in this video, right? So you definitely want to stay until the very end where I show it. But then, after you understand all the core principles that I'm gonna be explaining, you can just copy the repository and copy the dataset and run it for yourself, see how it works, and get already the working version done in pretty much like 30 minutes that took me multiple days to build. So talking about the tech stack, we're gonna be using Fastify for WebSockets. You already know, like if you have watched my videos, that I'm absolute fan of Supabase. So we're gonna be using it for database, both for vector database as well as for traditional SQL. We're gonna be using OpenAI Realtime API as well as GPT-4o to process some data. Then we're also gonna be using Google Calendar API to book appointments, as shown on the video. We also gonna be using Twilio to connect it to a real phone number, and we're gonna be using ngrok to host our server, right? So let's explore the basic thing that you can get running in very little time. It will be consistent of 4 different steps, namely user phone, going and calling the Twilio phone, transmitting the audio to it. Twilio phone, the Twilio thing will be connected to the Fastify through a WebSocket connection, as well as Realtime API will be connected to Fastify through a WebSocket connection, and that's where they will meet. So we can have a clear conversation between a user and a real-time API, right? Without any features, without any knowledge, whatever, just general knowledge from the OpenAI real-time API. And for this, I will not go explicit in how to get it running, but I link you here a video that you can follow. This video is from original Twilio account, and it walks you through all the setups that you need to do, which is very easy. It helps you set up your ngrok server, it helps you set up your Twilio account, it helps you configure your Twilio phone number to accept the webhook from your endpoint. And connect it all to the real-time API. So I hope you can figure it out on your own. As soon as you are done, please come up here, because we will be discussing various features that we can do. So let's be talking about OpenAI knowledge query process. Yeah, so we are using a vector database. Let me actually pull it. I just gonna do like this. So here I also give it to you in a code version. It's a dataset about Pokemons, all the different types of Pokemons, the evolutions and whatever, all vectorized, and you can get it under SQL load documents. Just put it in your SQL editor and you will have it running, yeah? But before, you also need table setups that will give you all the database tables, yeah? So after you got it running, let's go through how it all works. So you need to understand that all the functions that I will be going through right now, they're actually OpenAI function calls. Yeah, so a real-time API accepts function calling as well as structured output, so we can clearly define which functions it needs to call. So here the user asks something like, okay, tell me what is the exact height of a Charmander. This goes into OpenAI WebSocket, and because this question is very exact about a specific parameter about the Pokemon, it gets analyzed by real-time API and says, okay, for this I need to use the knowledge base. So we go to knowledge handler and we call the access knowledge base function. After that, we generate the embedding for the questions that user just said and put it to OpenAI embeddings. We return the vector embedding, and then we use an RPC call to search through Supabase. The RPC call can be found here. Search documents. This is a function, this is a SQL script that will create you a get similar document function, which is a very basic RAG function. which we'll be using to then search our vector database inside of Supabase and return the matching documents. Then documents will will properly use the data as well as the metadata and send the knowledge base to the WebSocket back. Then we will generate the response from Openai response using natural language processing and deliver it back to the user. We also have the edge case management for no documents found that will end up with no answer found and generate a response in terms of a fail to the user, so the conversation will not stop at this moment even if you don't find any documents relevant. This is how it works. Let's also dive in a little bit in the code at this point. So the main parts of the code that you need to pay attention to is this OpenAI message handler, which has all the different function calls for OpenAI for real-time API, as well as you need to be looking at session update. So let's first look here. So session update, it updates the OpenAI session because it first gets the default instructions like your helpful AI assistant, blah, 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 blah. So we override it actually with our system message that is in our .env file. And then we also have different functions. For example, here we have tools and we have type function access knowledge base. This is exactly the function to query a vector database. As you can see, access the knowledge base to answer the user's questions. This is how it is, right? Now let's go into OpenAI message handler, and here we have if function name is access knowledge base, then that's what we need to do, and at the end we do const await ask Supabase and our question. So now let's go and see what is actually ask Supabase assistant, right? And here it is. We are fetching, we are using the OpenAI embeddings to generate embeddings for the question. Then we are putting it, we are using the RPC function that is called search documents that I already showed you and given you the SQL script to create. And then we are basically finding the match, putting it back to OpenAI, and then generating answer based on the data. That's how it works. So I hope you don't have any questions at this point. If you have any, please always write in the comments, but let's keep moving. The next we'll discuss the booking system. So as you saw on the demo, we also have appointment scheduling. Yeah, we can say, please, I want to schedule a training session, and then AI will do multiple checks, multiple steps before it actually books the call. So let's look through the steps. We have user telling us that, okay, I want to book a training session, so request a booking. It goes to the system, and then AI needs to ask for preferred time if the user didn't provide the time in the very request, yeah? So let's imagine this. User says, I would like to schedule a training session for tomorrow. The user didn't mention explicitly the time, so AI will be prompted to ask for preferred time. After asking for preferred time, the AI will also check for the email history inside our database. If the user has a stored email, AI will spell it back to the user and say, do you want to use this email to schedule the call? If there is no email stored, the AI will request the email and wait until the user spells it. After that, AI will also spell the email back to the user to confirm it, and only after the user confirmed it, then AI will schedule the training session. It also can be that a user says, okay, I want to book a training session for tomorrow at 6 p.m. Then we already don't need to check for the time, but we just check for the email. Or user can even say, can I schedule a training session for tomorrow 6 p.m. with this email? And we also have the logic for this, yeah, with confirming of spelling, checking if the email is valid, and so on and so forth. What is important to mention is that we also have a lot of different states for this. So as you can see, the default state is idle, and after the user says that he wants to schedule a training session, AI directly goes into state awaiting time. So we need the time to schedule a training session. After the time was providing, we need yeah, we are going into confirm existing email. So AI looks up in a Supabase database in the users table if there is already an email for this user to schedule the training session for. If no, it goes into awaiting email. So it asks the user to spell the email and then awaits it. And then it goes into confirm email when it gets it and spells it back to the user, and it awaits the affirmative response from the user to actually make the booking of the training session, right? So let's again go through the code. Let's first go to the session update and let's see all these state transitions that are so interesting, right? So let me just find the thing. Yeah, here is schedule training session. Schedule a training session for user by collecting necessary details such as time and email. Yeah, this is our function call, and we also have type function retrieve user email from the database, and so on. Right. And now let's go into the Openai message handler and check how it works. So okay, here we had access knowledge base. That's great. Now let's go schedule training session. So if function name is schedule training session, then we are doing this. We need to first say preferred time. We need to also get the email, and only then we can successfully book and give this message. Yeah. So let's see the states that we managed throughout this process of booking. First, the state is idle, as I said you, and it stays in the OpenAI WebSocket. Then, after we are moving forward through the three-step process, we'll eventually retrieve, we'll eventually get the time. Yeah, so let's check for the time. Where is it? Where is it? Exactly. So look, else if booking state awaiting time, right? So here we are waiting for the time. We're also using different parsers for the time to understand, okay, 6 p.m. what is it exactly in the this timestamps format. Then we also have awaiting email, and if no, we are asking for the email, and else there was kind of some or else we couldn't find we couldn't understand the time provided. Can you specify it again? So we also have this handling. And then if we have the email, we are either confirming the email that user just said, or if the email already existed in the database and we didn't ask the user for it, we either way spell it back and ask the user if that's the correct email to use. At the end, we are confirming the email, and then we are going very back to the point where we schedule the training session and give this response, right? Okay, so this was the training session booking. Now let's look into the redirection logic. Yeah, so as you can see in the demo, we also redirect the call to a completely different phone number in case investment inquiries. Yeah, so let's look how it all is built. We have the user who says to the Twilio number that, okay, I would like to invest in a new Pokemon facility. After that, we are immediately going into a new state, which is awaiting investment confirmation. So we generate an AI message to say, okay, that sounds exciting. Are you ready to be redirected to a fundraising expert that can assist you further, right? So, and here we have a special function which confirms that it is an affirmative response. After that, the state is set to idle back, and we use the redirect to fundraising expert function to then change the direction of the call. Yeah, we are creating a Twilio response and set up the dial parameters so that we make a call to a completely new number. If not, then we also have the handling for a negative response from the user. Let's dive deeper into the code, see how it looks. So let's see how we handle the state. Well, let's first see the session update. So here we have handle investment inquiry, and I guess we also have awaiting. No, we actually don't. Invest. Let's see if we have something. handle investment no, okay, we don't have the await as a function. And let's dive into the Openai message handler, and here we also look for handle investment inquiry, and here is how it works. Yeah, so we are going into await investment confirmation. Then as soon as we are done with investment confirmation, received confirmation, then we actually go and process investment confirmation to then redirect. And let me also show you how we actually do the redirection. So let me just search redirect to fundraising. Okay, yeah, so it's here. As you can see, we are creating a new voice response from the Twilio client and connecting it to our fundraising expert now. And then we use the Twilio dial function to redirect our call. Here we are collecting the call status, and we are sending a post request basically to this phone number, which is my actual phone number where I redirected to. And that's how it works. And here is how we process the investment confirmation. We are using is affirmative on the confirmation, and if it's affirmative, we are then already going and setting state back to idle and performing the function call to how it's called, to redirect to fundraising expert here. Yeah, as this is how it works. And here we also have the handle call status to just monitor the call status. You may ask what is affirmative, which is very important, but it's basically is just a simple simple affirmative patterns that we defined as so. So it's not an actual another LLM call just to make it faster, because it's not needed here. Yeah, it can be kind of confusing for AI to detect it, so it's just easier to do it as follows. Okay, now we got the redirection logic done. Let's also talk about all the data management throughout this process. Yeah, so as you saw on my database, we have here a lot of different stuff. So we have here conversations table. Yeah, so we have a conversation ID that is connected to the phone number. Let me actually show you the whole database as so. So look, we have here the users table, which has a phone number, name, email, and created ad. We have all the conversations stored, where we have conversation ID connected to the phone number from the user, which is a unique identifier. We have a full dialogue from each conversation, and we are using additive principle, so it doesn't get updated, but each conversation is a new row in the database. We also have a summary, so basically after a conversation is finalized, we have a function which calls GPT-4o, and it finalizes all the conversation based on the full dialogue. Then, start timestamp, end timestamp, just to track when the call was. We have the last question and last answer. We also have bookings. Booking ID is basically event ID from Google Calendar API. Phone number is unique identifier, and conversation ID links to conversation from which this booking was created. Booking state to manage the state. Booking time, basically when it was. Booking email, because sometimes it differs from the user email, and created that. Yeah, why we have booking state and we don't manage it in memory is because sometimes a user can start scheduling a call, but then somehow, for example, let's say drop off the call in the middle of the process. For example, he gave the time but not the email, and then when he calls again, the AI will already say, I remember you wanted to schedule this training session. Do you still want to do it for tomorrow at 6 p.m? Can you please tell me your email? Yeah, so it kind of improves the user experience. We have the documents that I already showed you, and we have the long-term memory, which we'll cover a little bit further down the line, and it has ID, phone number is unique identifier, conversation ID, where it was used, context, embedding, and created ad. So it's also another vector database for long-term memory to store the context in. Right, so let's now talk about the data management. So, okay, so here, when a user calls, we immediately check if the user already exists. If no, then we create the user. If yes, we fetch the user data. And what the data can be is basically the conversation history as seen here. We're getting the last conversation plus the username for us then to generate a personalized greeting. I will also talk about this in a bit. We also have email query. Yes, so for example, we immediately get the user email, so when he asks for booking, we're already ready and set up with the emails that is already in the OpenAI kind of knowledge, and it says, oh, we already actually have your email, do you want to use this for the booking? Yeah. Well, we also update the username, update the user email based on the context. Here is also the conversation management, and we update the conversations. In some cases, in the majority, we just add up different conversations and we create this here. Here we can also see the booking management, so we manage a lot of states, which is basically from booking ID plus state. We update the booking state across different bookings or across one booking in two different calls, as I already mentioned in the example before. And here is just basic booking state management. Also, something important to mention here is because you know that we also store all the conversation history. Yeah, if you open, for example, here table, and we open conversations, let's say full dialogue here. Yeah, so how we do it? It's actually because we are using the call SID from Twilio webhook handler, and we pass it with every single message kind of to make sure that it acts as a unique identifier for the message, so it means that it refers to the same conversation. And then we are adding up all the messages with the same caller ID. And actually in the database, as you see here, conversation ID, this ID is the call SID, right? Let me show you how it's actually done here, the whole finalizing of the conversation. So here is the logic for update the username, pretty basic. Then we have here the finalized conversation thing that basically is a call to GPT-4o, which says, okay, can you please finalize this conversation and generate a summary based on the full dialogue. Here it goes. And it also updates the email. If it retrieves some email, it extracts the name from the summary. It updates all the stuff, it extracts relevant info and puts it into long-term memory, and so on. Here we also have the extract username from the summary, which is again another function call to GPT-4o. We are updating the booking states, setting it back to idle most of the time. We are retrieving the user email as follows. Let me actually see from the utils if we also have some cool stuff here. Here is update last conversation in case we need to update it, and no, nothing much more. Well, let's keep cruising and now talk about long-term memory. So here, when the user query comes, we get long-term memory if it fits the context. Yeah. So here, if we look through, let's go here in long-term memory, we actually have different topics that we want to track as long-term memory. So in my case, it's birthday, favorite Pokemon, allergies, parents' names, and address. And this is a function that takes the full dialogue and then analyzes the dialogue if it has anything related to this, and if it does, it stores this as a long-term memory. And the database for long-term memory is basically the same structure as for documents, so it's a vector database. And we store it here, so this is a function to store it, and we also get the long-term memory from already stored data in the context when it's needed, and it works exactly the same as the querying of the knowledge base. Yeah, so it's again a RAG system, and we trigger a function access long-term memory. We generate the embedding, as you can see here. We're generating the embedding, and then we are going through the RPC call, which is basically here search long-term memory. You can also copy and paste into SQLite to get it. We return matching documents, and then we put it all into OpenAI WebSocket to create the answer. Yeah, so here is kind of more detailed flow. Yeah, we RPC call search long-term memory. We format the response. AI process it. And then we also here have the extraction. So here are the topics: favorite Pokemon, allergies, parents' names, address, whatever. Yeah, and at the end we also format it all into valid JSON, and we store it in the long-term memory vector database, right? While extracting relevant info. And the last thing to cover is how to make AI to talk first. Yeah, that's something I would say that's the most difficult part, not because it's difficult from the engineering side, but because it was just kind of hard to imagine how to get it running. So all the things that you need to understand is that to make it running, you need to actually talk first. But then you don't want to talk first, you want AI to initiate the conversation. So what we do here is we are passing, like behind the line, we are passing a message, and behind the scenes, we are passing the message to AI, and it already generates a response to it, and this response will sound to the end user as the first message, as if AI starts the conversation, which is kind of not true. Yeah. So we are fetching the call details from Twilio. We are fetching the call SID, extracting the phone number, storing it in the WebSocket if it's needed, and then we get create the user with retry and create the conversation. Yeah. We also retrieve the last conversation to formulate this last message. Yeah. So we also here, you remember I was talking about bookings, like about the same booking in two different calls. So we also need to check if the state is idle. If yes, then we use the default welcome prompt, which is basically, hey, the last thing we talked about was this, based on the previous conversation summary. Do you want to continue talking about this, or you have something else in your mind? Yeah. If the booking state is not idle, we also summarize the last topic and we return the returning user message prompt. For example, I remember you were scheduling the training session at 6 p.m. tomorrow. Do you want to continue with that? Blah, blah, blah. Then we send this kind of prompt, and we, in a sense, we prompt AI to say this. And then AI will respond with blah, 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 exactly what we prompted it to. So it's a lot of kind of prompt engineering that you will see in the code base, right? And here is how AI initiates the conversation. Yeah, so if it's a new user that is calling, then there is a default prompt that says, hey trainer, would you like to discuss Pokemons? How can I assist you with that? Blah, blah, blah. So this is basically the secret sauce on how to get AI to talk first, and let's see it here. Also in my .env I have more detailed prompts. I will just put them somewhere here in the, like directly on top of the video, because I don't want to show you my .env and then blur it all. So I will just put you some prompts that you can use and how I'm handling it. And this is how I get AI to talk first. Yeah, so it's kind of a thing of passing the prompt behind the back of the user, so that he doesn't see it, but and thinks that it's actually AI initiating the conversation and not we making it talk through a prompt behind the scenes. So this is pretty much it. This is what I've achieved so far. I think it took me around like a week of work with some pauses to make all this happen. I hope it was pretty clear. Again, please make sure that you check out the code, that you go through it yourself. It will just take me too much time to kind of recreate it all from very zero to the state it is here right now. So I encourage you to kind of just understand the diagrams that I'm talking about here, that I'm explaining, as well as just cloning the repository and configuring the dataset, configuring the prompts for yourself and using it. I also put you here an environment example with all the stuff that you need to be using. For example, here I was using a lot of Azure endpoints, but you may use it with normal GPT. All the Google IDs you have here, the system message, the Twilio accounts, ports, everything that you need to make it running. So I hope you enjoyed this video. If so, and if you will if you are planning to use any of this functionality in your company or for your personal use, just to train or build something fun, please make sure to start this repository on GitHub. It will help me really a lot. Here it is. It also has a really nice README with all the diagrams and explanation on how to run it all. And the link to the Twilio message that got me starting and that should get you starting with the basic connection of this. So please make sure to give it a star, give a like to this YouTube video. I hope you enjoyed it and I hope it was useful for you. So I see you in the next videos. Take care.